Hello students, I welcome all of you to Infinity Learn JEE by Sri Chaitanya. So students, what we are going to discuss now is about the 31st January shift to JEE paper analysis. So over here we are going to look into all the 30 questions which have been asked in shift 2 of 31st Jan, and we'll be also knowing about the key strategies from whichever topic they have been asked, from whichever chapter they have been asked, and also the solution as well as the final answer, what is going to be the correct answer for that question. My personal advice to all the students, whoever are seeing the question, so please whenever you see the question, try to attempt on your own, and after that go ahead for the solution part. So moving ahead, let's bring in front of us the very first question which we have, that is from gravitation, from escape velocity. Now the mass of the moon is 1 upon 144 times the mass of a planet, and the diameter is 1 by 16 times the diameter of a planet. If the escape velocity on the planet is v, the escape velocity on moon will be. So it's a very simple formula, that escape velocity is under root of 2 times gm upon r. Based on this, you can very easily find out the answer, what is going to be the escape velocity of the moon, because the radius you can compare with Earth, as well as you can compare the mass as well with also Earth. So the correct answer over here is going to be answer number 4, and it's just the application of this formulation over here as has been expressed in front of you. Moving ahead for the next question, a uniform magnetic field of 2 into 10 raised to the power minus 3 Tesla acts along positive y direction. Okay, a rectangular loop of side 20 centimeter and 10 centimeter with current of 5 ampere is in YZ plane. The current is in anti-clockwise sense, okay, with reference to the negative axis. The magnitude and direction of the torque is. So basically in the YZ plane, you have a current carrying loop. Okay, so let's say this is my Y and this is basically my Z. So we have a current carrying loop which is placed in the YZ axis like this, and there is current, there is uniform magnetic field which is running along the positive Y, right? Along the positive Y, just like this. This is the magnetic field line, right? And there is anti-clockwise current which is flowing in it. Am I clear? So obviously there's going to be a torque, there's going to be a magnetic moment with respect to this loop in the dot direction, and that magnetic moment present in the magnetic field lines will obviously cause a torque that will be given as m cross b, right? So now you can see, you can very easily find out the answer based on that formulation, and the direction also you can determine. See, m vector is over here. So m vector is over here, b is over here. Obviously it is going to be along the negative z axis, and based on that, option number 2 is the correct answer. So negative z direction obviously, and the magnitude is going to be 2 into 10 raised to the power minus 4. Okay, so this question basically was not of calculating or knowing the formula. It was just that if you are able to calculate the direction, then you can very easily find out the answer. Okay, so it was majorly based upon your analysis, your diagram analysis, if you are able to draw that. Now moving ahead, given below are two statements. Statement 1 is electromagnetic waves carry energy as they travel through space, and this energy is equally shared by electric and magnetic fields, right? When electromagnetic waves strike a surface, a pressure is exerted on the surface. Absolutely correct, absolutely correct. So option number over here, just a minute. Option number 1 is the correct answer. Both statement 1 and statement 2 are correct. Yes, they definitely exert a pressure also on a reflecting surface, that is 2I by C, and also they carry energy both in electric and magnetic field lines. So this was a statement based question, very simple, based on theory only. Option number 1 is the correct answer. EM waves carry energy as well as momentum also, and they carry momentum, that is the reason they exert force also. Okay, now a gas mixture consists of 8 moles of argon and 6 moles of oxygen at temperature T. Neglecting all vibrational mode, the total internal energy of the system is. So these kinds of questions have been asked previously also of the mixture. They are actually asking the final gamma of the mixture, that is the adiabatic constant, or in this scenario they are asking about the total internal energy. So basically for any gas, any mole of gas, it is NFRT by 2, where F is the degree of freedom of that gas and N is the number of moles. Simply if you use that formula, NFRT by 2, where F is the degree of freedom. So for argon, since it is mono, the degree of freedom will be 3, and for oxygen, since it is diatomic and all vibrational mode have to be neglected, the degree of freedom is 5. Based on that, you can just place over here and the number of moles are given. You can very easily find out the answer. Answer is option number 1, that is 27 RT. As you can see, it's simple, NF RT by 2. 27 RT is the correct answer. Simple question. Moving ahead for the next one over here. In a photoelectric effect experiment, a light of frequency 1.5 times the threshold frequency is made to fall on the surface of photosensitive material. Now, if the frequency is halved and the intensity is doubled, the number of photoelectrons emitted will be. It's a very simple one. If suppose the frequency is not greater than the threshold frequency, obviously the electrons will not come out. And this is what they are saying. So right now it is 1.5 times a particular frequency, 1.5 times, let's say threshold 1. If you are halving it, that will become 0.75. That will not be more than the threshold frequency. So no photoelectrons will come out. Option number 4 is the correct answer. Simple, you need to observe it and you will get the answer. Okay. Now, when unpolarized light is incident at an angle 60 degree on a transparent medium from air, the reflected rays completely polarize. So this is polarization by reflection. The angle of refraction in the medium is, this is a very standard case of Brewster angle, wherein the angle between the reflected light ray and the refracted light ray becomes 90 degree, and based on that you can very easily find out the angle of refraction. The scenario is somewhat like this. There is incident light ray, the reflected light ray goes over there and the refracted light ray goes over there, and the angle is 90 degree over here. In this scenario you get polarization happening at this place. Okay, so option number 1 is the correct answer over here, and it's just a case of, as is the diagram in front of you, it's just a case of Brewster angle. Based on just diagrams you can just find out the correct answer. The mass number of nucleus having radius equal to half of the radius of nucleus with mass number 192 is. So the mass number of a nucleus, what is going to be the mass number of a nucleus which is having radius equal to half of the radius of nucleus, half of the radius of the nucleus with mass number 192. So you are knowing that the radius of a particular nucleus is R is equal to R naught A raised to the power 1 by 3, right? So based on this, the atomic mass is given for this two of them. The radius mass number 192 is given, and the mass number of a nucleus. Okay, you need to find out the mass number of a particular nucleus, and the other mass is given, and they have given the ratio of the radius. So based on this expression, simple, option number 4 is going to be the correct answer over here, and you just need to use this expression over here. So the radius whole cube will be the atomic mass over here. Okay, done, sir. Consider two physical quantities A, B related to each other as E is equal to B minus X square, where E, X and T have dimensions of energy, length and time. Okay, the dimensions of A, B is. So you need to find out, these type of questions have been asked in the exam. So dimension of B will be that of L square. The dimension of A will be equal to E into T. E into T upon X square. So the dimension of A will be equal to E into T will come over here and X square will be over here. So L square divided by energy into time. This is going to be the dimension of A, and B obviously will be L2. So based on that, you can very easily find out the answer, what is going to be the result for A into B, and through that you can find out the answer. I don't think there is nothing much to do in this. Option number 4 is going to be the correct answer over here. This is the entire expression over here. The measured value of the length of a simple pendulum is 20 centimeter with 2 mm accuracy. So another question you have of errors. So basically from units and dimension, 2 questions. The time of 50 oscillations was measured to be 40 seconds with 1 second resolution. So basically you need to find out the time for one oscillation, that is going to be 40 by 50, and also this 1 second resolution will be your least count error, and that will also reduce to 1 by 50. Okay, from these measurements, the accuracy of the measurement of acceleration due to gravity is, this is a very standard problem given in NCERT also, and you need to solve based on that, and option number 4 is going to be the correct answer. Basically you need to find out the value of delta L. Delta L by L is given. Delta L is 2 mm and this is 20. So that's going to be easy. But the main point will be over here, delta T by T. So delta T by T simply will be, you have time period for 50 oscillations, that is 40 seconds. So what is going to be the time period for one oscillation? One oscillation, the time period is going to be 40 upon 50. And for this entire 50 oscillation, you will have a delta T of 1 second. You have a delta T of 1 second. So the delta T will be equal to 1 upon 50. This is going to be a delta T by T. Now you just need to, and this is going to be 2 mm divided by 20 centimeter. Now it's simple, delta G by G, T is equal to 2 pi under root of L by G, right? So G will be equal to 2 times delta T by T plus delta L by L. This is how you are going to relate. Okay, this is the expression given over here. This is delta T by T, and you can very easily find out the answer. Okay, done, sir. Moving ahead for the next question over here. The speed of sound in oxygen at STP will be approximately given as. So this is a standard problem, but basically what happened is, based on the values, you will not get any answer which is amongst them. So the correct answer over here is normally 314 meter per second, right? But the correct answer given in the answer key was option number 1. Maybe based on approximation, but the correct answer over here is 314. So you should get a bonus over here, but in the answer key it was 310. So based on that, we will assume they have approximated, and 310 is the correct answer. But the correct answer, obviously, if you keep these values, it's going to be 340. The correct answer over here is, so it is going to be gamma RT upon m naught. This is the velocity of sound. This is the velocity of sound. You need to keep the mass of oxygen over here in kgs, then R, T and gamma. You will get the speed of sound. That's going to be around 340. But yes, option number 1 is the correct answer over here. Okay. Then moving ahead, a question from NLM. A block of mass 5 kg is placed on a rough inclined surface as shown in the figure. If F1 is the force required to just move the block up the inclined plane and F2 is the force required to just prevent the block from sliding down, then the value of F1 minus F2 is. This is a question, and over here also none of the options were correct. None of the options were correct. The correct answer which you are getting was around 5 root 3. 5 root 3. But there was no option which was matching this. So people got this as a bonus. Okay. When you will use this based on this methodology, then the correct answer will be 5 root 3. But this question came out as a bonus. When AC voltage of V is equal to 20 sin 200 pi t is applied to a series LCR circuit which drives a current I equals to 10 sin 200 pi t plus pi by 3, the average power dissipated is. So basically the average power which is going to be over here, that's going to VRMS into IRMS into cos of phi. So you can very easily find out VRMS, IRMS and cos of phi. This is going to be the phi over here. Simple formula will fetch you the result as option number 1. As you can see over here, VRMS, IRMS into cos of theta, where cos theta is the power factor. Okay, 50 watt is the correct answer. Talking about the next case, the resistance per centimeter of a meter bridge wire is R with X ohm resistance in the left gap. Balancing length from left end is at 40 centimeter with 25 ohm resistance in the right gap. Now the wire is replaced by another wire of 2R resistance per centimeter. The new balancing length of same settings will be. It's a very simple standard case of meter bridge. Draw the diagram. This is the solution in front of you, and based on this formulation, you will get the correct answer as option number 3. That is 40 centimeter. Okay, simple problem. Talking about the next one over here, that is a small spherical ball of radius r falling through a viscous media of negligible density has terminal velocity v. Another ball of the same mass but of radius 2r falling through the same viscous media will have terminal velocity. So basically you need to remember the expression of terminal velocity in fluid mechanics, how it is related with the radii of the molecules. And once you know this, that velocity is directly proportional to the radius, you will finally get the answer that is turning out to be option number 2, that is v by 2. So you just need to remember how the terminal velocity is varying with the radius of the spherical ball. Okay, next, the force between 2 point charges Q1 and Q2 placed in vacuum at r centimeter apart is F. Forces between them when placed in a medium having dielectric constant K is equal to 5. Dielectric constant K is equal to 5 at r by 5 centimeter apart it. So it's a very simple result. They just need the application of Coulomb's law, that is 1 upon 4 pi epsilon naught Q1 Q2 by r. In place of epsilon naught, you need to write down 5 times epsilon naught. Okay, and the radius is also going to be r by 5. So simply solving, I hope everyone got this as the correct answer. The correct answer is 3F, and you just need to use Coulomb's law over here, you will get the answer. By what percentage will the illumination of a lamp decrease if the current drops by 20%? So the analysis over here is simply based on that brightness is directly proportional to the power. Okay, brightness is directly proportional to the power, and power is simply equal to I square R. It is equal to I square R. I square R. Okay, so based on that, you can very easily find out the ratio. Whatever is the ratio, the radius is same. Sorry, the resistance is same, only the current is changing, and based on that you will get a change of 36%. So this is going to be the increment. So the percentage drop in the illumination will be of 36%. Always remember, illumination is all about energy which is getting dissipated per unit time, and that simply speaks of the power. So illumination is your power only. A body of mass 2 kg begins to move under the action of time dependent force given by F is equal to 60 I cap plus 6t square j cap. The power developed by the force at the time t is given by. What is going to be the power developed by the force at the time t? So the power developed over here is going to be integration of f dt. Integration of f dt, it's going to be the total power which will be generated in the circuit. You need to integrate it. And then find out the final answer. Begins to move under the action of a time dependent force given by. Okay, first thing first, with the help of this force, you need to find out the acceleration, right? And then with respect to this acceleration, you need to find out the velocity. And then the power, they are asking about the power developed by the force. So power over here is going to be F dot V. Then you are going to get the correct answer over here. So this is a standard problem. A bit of calculations will be required, but you will be able to solve it. Option number 1 is going to be the correct answer, that is 90 cube plus 6t raised to the power 5. First you need to calculate the acceleration, then you need to calculate the velocity over here, and you will be able to find out the answer. Okay, I hope this is clear. Okay, done. If two vectors A and B having equal magnitude r are inclined at an angle theta, then so this basically speaks of the magnitude. What is going to be the magnitude over here? It's a simple problem. Option number 2, it's a very standard case. Option number 2, that is the magnitude of A plus B is going to be 2r cos of theta. Okay, so you can very easily find out if A plus B, for A is equal to B is equal to r, is this the answer? Okay, and this is the data which they have given also. If two vectors having equal magnitude r are inclined at an angle. Okay, then talking about this. So over here, this is a logic gate case. Here you have a NOT gate, here you have a NOT gate, and the input of A is going over here and it is going over here also. The B is going over here, the NOT gate, and the B is going over here also. This is an OR gate and this is a NOR gate. Okay, so based on this, you can create a truth table, and they are asking about the final output only. So what is A and B and the final Y over here? Based on the options, option number 4 is going to be the correct answer over here, and I hope you have understood it. Right? Now, a light string passing over a smooth light fixed pulley connects two blocks of masses m1 and m2. If the acceleration of the system is g by 8, then the ratio of masses is. You just need to find out the ratio of masses, and the acceleration of the system is actually given as g by 8. Simple NLM question. You just need to draw the free body diagrams and you will get the answer. Just create two equations, you will get what is the ratio of m1 is to m2. The correct answer over here is going to be option number 1, that is 9:7. Okay, 9:7 is the correct answer. In the following circuit, when the battery has an EMF of 2 volt, so here is a battery, and an internal resistance 2 by 3 ohm, the power consumption in the entire circuit is. So what you can do is you can just construct the entire circuit. As you can see, this point is A, this is A, this is A, this is B, this is B, and this is B, and you can consider this point to be C. So if you will see over here, this is a circuit between A and B, this is between A and B, this is AC, this is AC, this is BC, this is BC. These two are in parallel, these two are in parallel, and these two are in parallel. Once you draw the net equivalent resistance of this entire combination and find out the value of current, the power consumption in the entire circuit, you can find very easily. So answer is going to be 3. 3 is the power dissipation or the power consumption in the entire circuit. Moving ahead for the next one, as you can see, this is the answer over here. Two blocks of masses 2 kg, 4 kg. So another question of Newton's laws of motion. Previous one was from current electricity. Two blocks of masses 2 kg, 4 kg are connected by a metal wire going over a smooth pulley as shown in figure. The radius of wire is 4 into 10 raised to the power minus 5 meter, and Young's modulus of the metal is this much. The longitudinal strain developed in the wire is this much. The value of alpha is. So what you need to consider is the tension, whatever is the tension in the wire, and the tension in the wire divided by area will give you the value of the stress, and longitudinal strain you can calculate by dividing that stress by the Young's modulus. So what all data has been given? The radius has been given, so you can find out the area, that is going to be pi r square. Stress you can calculate, tension you can calculate very easily over here, and based on that, the longitudinal strain you need to compare with 1 upon alpha pi and find out the value of alpha. So correct answer over here will turn out to be option number 12. This is the correct answer. That is 12 over here, okay? And the calculations are as expressed over here. Moving ahead for the next one. So here is a combination of springs. This is a nice question. The time period of the simple harmonic motion of mass m in the given figure is. So basically these two are in parallel, then they are in series, and then the combination will be in parallel, okay? Now based on that, you can find out the net effective capacitance, and finally the time period will be 2 pi under root of m upon k. So in place of k, you need to write down k effective and compare it with pi alpha m upon 5k. You will get the answer as again 12. This is the correct answer over here, that is 12. So the k equivalent will turn out to be 5k by 3. When you place it over here, you'll get the correct answer, okay? Moving ahead for the next one, two identical spheres each of mass 2 kg and radius 50 centimeter are fixed at the ends of a light rod so that the separation between the centers is 150 centimeter, okay? Then moment of inertia of the system about an axis perpendicular to the rod and passing through its middle point is. So basically the case is over here like this, okay? You need to find out the moment of inertia about this point. So first you need to find out the moment, the rod is right, okay, the rod is right, so there is no going to be moment of inertia of this rod. Basically you need to find out the moment of inertia of this sphere, solid sphere, considering it to be solid sphere about this axis, solid sphere about this axis, and through parallel axis theorem you need to find out the moment of inertia about this one, okay? So this is about COM, this is about COM, and about this is going to be ICOM plus MD square, ICOM plus MD square, and you'll get the answer as x by 20 kg meter square, and finally on comparison you will get 53 as the correct answer, okay? 53 as the correct answer over here. Since there is no mention about, one thing to notice over here is there is no mention about the type of sphere, whether hollow or solid. So in those cases you consider it to be solid sphere only. You consider it to be solid sphere only, okay? I hope this is crystal clear to everyone. Moving ahead for the next one, a body of mass small m is projected with a speed of u, making an angle of 45 degree with the ground. The angular momentum of the body about a point of projection at the highest point is expressed at. So this is a very standard problem of projectile motion and basically of angular momentum. You need to find out the angular momentum of this body about this point, that is the point of projection, okay? So the angular momentum, whatever it is, it's simple, this r perpendicular, this is the r, but you need to multiply r perpendicular into this p. That is going to be h max into the m vx, that is mu cos theta. It's a very standard result. The final answer will be option number 8. When you will place and the value of x they are asking, okay? So this is the final figure, and through that you will get the value as mu cube upon 4 root 2g. And there is a root 2 over here, so root 2 will be multiplied, ultimately you will get x value as 8 only. Moving ahead for the next one, the distance between charges plus q and minus q is 2L, okay? And the distance and between plus 2q and minus 2q is 4L, okay? These are the diagrams. The electrostatic potential at point P at a distance r from the center O is alpha QL upon r square into 10 to the power 9 volt, where the value of r is. So you need to find out what is the potential over here. So you have one dipole over here and you have another dipole over here. So you need to find out the net potential because of both of them, because of both of these dipoles, and I hope you remember how you calculate the electrostatic potential. So you need to break down the components along this one, right? And the potential at axial position is some value, but at equatorial position, so whatever is going to be the sine 60 component, the net potential will be 0. So you just need to check for the axial component also. So because of this, it's going to be towards this, because of this it's going to be negative, because of the smaller one it's going to be positive. So ultimately the answer will be negative. That is the reason there is a negative given also over here. Once you will calculate, the answer will be answer 27. So 27 is going to be the value of alpha. 27 will come over here. As you can see, this is the approximation. Obviously r you need to consider extremely greater than L, then only you can find in this manner. So it's just going to be because of the cos theta component only, and finally answer will be 27 over here. Moving ahead for the next one, the magnetic flux phi linked with a closed circuit of resistance 8 ohm varies with time as phi is equal to 5t square minus 36t plus 1. The induced current in the circuit at t equals to 2s. So induced current will simply be equal to whatever is the EMF divided by the potential resistance. EMF can be calculated as d phi by dt, and resistance is given as 8 ohm. So the EMF divided by the resistance will give you the value of the induced current, and you can very easily find out at t equals to 2 seconds. Okay, option will be, correct answer will be 2. 2 is the correct answer. Okay. Two circular coils P and Q of 100 turns each have same radius of pi centimeter. The current in P and R are 1 ampere and 2 ampere respectively. P and Q are placed with their planes mutually perpendicular with the centers and they coincide. Yes, the resultant magnetic field induction at the center of the coils is this much. This is also, this question has been repeated. Only the fact is the number of turns is now 100. So one coil will be over here, another coil will be over here. Obviously, because of both of them, the magnetic field lines will be perpendicular. The magnetic field lines will be perpendicular, and final answer will be, you need to take the under root of them, because see, the current is also different. The current is different. The current of both of them is different. One is having I1, another one is having I2. So one will be having B1 and another will be having B2. So you need to find out the net resultant, the resultant magnetic field they are asking, right? Correct answer is going to be under root of 20 milli Tesla, I hope, right? Yes, under root of 20 milli Tesla. And the net will obviously be equal to under root of B1 square plus B2 square. Both of them will be different. A similar type of a question was asked in one of the shifts wherein the magnitude of current was same and the magnetic field was same. So over there the answer was pretty simple. It was just root 2 times whatever magnetic field you are getting for any one of them. Okay. So B1 will be this, B2 will be this. As you can see, they are having different values, and B will be under root of B1 square plus B2 square. Now nucleus has mass number A1 and volume V1. Another nucleus has mass number A2 and volume V2. If the relation between mass number is A2 is equal to 4 times A1, A2 equals to 4 times A1, then V2 is to V1 is, what is going to be the value of V2 is to V1? What is going to be the value of V2 is to V1? So V2 is to V1, they are given the mass number. Now mass number is related with radius as cube of the radius, right? So mass number is basically directly related to volume only, right? So with this, you can very easily find out the answer. The option will be 4 only, because whatever is the volume, that is related to mass number directly. So A2 is to A1 is 4, that means V2 is to V1 will also be 4 only. Okay, this is the correct answer. Light from a point source in air falls on a convex curved surface of radius 20 centimeter and refractive index 1.5. If source is located 100 centimeter from the convex surface, the image will be formed at. So this is basically refraction. This is basically refraction at a curved surface over here. This is 1.5 nu, and over here the nu is 1, and the object is given, the image will be formed. You just need to find out the image. So it's a simple formula, mu r upon v minus mu I upon u equals to mu r minus mu I upon capital R. Based on this, the correct answer will be 200. So simple formulation, this is what I've just told you. You can very easily find out the correct answer over here. Everything data is given, correct answer will be 200 over here. Okay, I hope you have understood this. So with this, we actually come to an end to the discussion of 31st January shift 2 exam. Overall, on a difficulty level, it was from easy to mediocre level. There were not many tough questions. There were some calculative questions, but overall, the level was below medium level. And I hope you all who have answered this question were able to analyze and decode what has been asked to you and were able to solve it also. It is very important for all the students who are going to appear for the next session as well as for the upcoming JEE Main sessions for 25, 26 and all those coming years. So with this, we are going to close this session. I hope you have liked it. Thank you and bye-bye to all of you.